Hi everyone, I'm Tanya from Physics Mastery. In this video, we are diving into IGCSE Physics, Paper 6, Alternative to Practical, May June 2025, Paper 61. Question by question. Right, so grab your pen, your calculator, your ruler, your eraser, and maybe some snacks. Let's jump straight to question number one. Now, question number one, the student determines the density of a ball. A, he places the ball between two wooden blocks as seen from above in Fig 1.1. He takes two measurements D1 and D2. First part on Fig 1.1, measure the lengths D1 and D2. Now, before I give you the answer for D1 and D2, let me remind you again. This is alternative to practical or written practical. So if you want to do this past your paper, you should set the setting on your printer. You should print out this paper in actual size so that your measurement of D1 and D2 would be as accurate as possible. So I did print out actual size and the measurement of my D1, right? Before that, okay, about D1 and D2, you are definitely using your cm rule, 15 cm or 30 cm rule to measure D1 and D2. Before you record your reading of your measurements of lengths of D1 and D2, please bear this in mind. As long as you use apparatus, your cm rule serve the same purpose as the meter rule in the lab. So that is also being called one of the apparatus. So as long as you are using apparatus, you have to denote or record the readings by following the decimal points of the sensitivity of that particular apparatus. Since I'm using a cm rule, and the sensitivity means the smallest scale on that cm rule, which is 0.1. So the smallest scale is 0.1 cm. Therefore, your D1 and D2 values must be recorded in one decimal point. So I'm going to put it as 2.7 for D1 and 2.5 for D2. So you measure using your cm rule. Now, the second part, use your measurements, calculate the diameter D of the ball. So diameter D would be the average value of D1 and D2. Do you see this word? If you see this word calculate, meaning to say that you're using your calculator to do your calculations. As long as you're using your calculator or you do your calculation, see how I do. The value of D must follow the significant figures of your D1 and D2. So I put D1 2.7 plus 2.5 divided by 2. Since D1 has two significant figures and D2 has two significant figures, the significant figure for the diameter D must be in two significant figures as well. So I got 2.6 cm. So 2.6 cm. And the third part, explain why this method is used to measure the diameter of the ball. Maybe this method, because the best method is not the method, the best apparatus to be used to measure the diameter of the ball is actually called micrometer screw gauge. Maybe during the experiment time, the student is not being provided with micrometer. That is why this is the best method to measure the diameter of the ball, because the ball is curved, right? It is not straight. So that is why you have to use your wooden blocks, maybe your blocks to block the ball from. First one, block the ball from rolling over the table. And second is to lock the ball, and then because the ball is curved, so each part, okay, because we are using wooden block is straight. So that is why we measure different length to find the average of the length, which is the diameter of the ball, right? So if a meter rule is being used, can you imagine that you place the meter rule on the ball, right? So you know that the ball is curved. You place the meter rule. First one, the ball might be moving. Second, okay, how do you make sure that your eye level is perpendicular to the scale on the meter rule? So it could easily cause parallax error. So which causes your reading to be very, very inaccurate, right? So I would say that. So this method is being used. First one is because, okay, if a meter rule is placed on ball to measure its diameter directly, ball might be moving and parallax error. Parallax error occurs. Parallax error occurs. Parallax error is the error due to the eye position, which is not perpendicular to the scale on the middle rule. Now, B, calculate volume V of the ball using the equation V is equal to 0.52 d cubed. Include the unit. So V is equal to 0.52. If you want to change the D to meter, it's up to you, totally up to you. But I'm not going to change that. I'm just going to put it in cm. So I'm going to cube it. And I got 9.1 cm cube. You see, two significant figures. So 9.1 cm cube is the answer. Now, see, the student measures the mass mg of a dish, which is equal to 102.5 gram. He places the ball in the dish and measures the combined mass mc of the dish and the ball. Fig 1.2 shows the dish and the ball on the balance. Record the reading shown on the balance. No mark will be given because we just copy this 114.1 gram. Calculate the mass mb of the ball. Show your working. Mass of the ball must be equal to the mass of the dish plus the mass of the ball minus the mass of the empty dish, which is 102.5. Right, so you will get 11.6 grams. So I'm going to put it 11.6 grams. Calculate the density rho of the ball using the equation. Rho is equal to mb over v, and give your answer in the suitable number of significant figures for this experiment. So when they say significant figures is very important, so I'm going to put this 11.6 divided by the volume. Remember the volume just now, which is 9.1. So I'm going to sub it as 9.1 cm cube. So this is in gram, this is in cm cube. So since 9.1, I'm going to follow the significant figures of 9.1, which is two significant figures. So since 11.6 has three significant figures, so you can choose to put rho as 2 to 3 significant figures. So I'm going to put it as two significant figures, which is 1.3 gram per cm cube. 1.3 gram per cm cube. You definitely can put it as three significant figures, which is 1.28 times 10 to the 1.28 gram per cm cube. Now, question number 2. A student investigates the cooling of hot water in a beaker. The apparatus is shown in Fig 2.1. A, the student uses a thermometer to measure the room temperature, theta R. Room temperature is 22 degrees Celsius. So on Fig 2.2, show clearly the reading of theta R. This is 20, 21, 22 is here. This is 22 degrees Celsius. Now, B, the student pours 100 cm cube of hot water into an empty beaker. She records the temperature theta of the hot water in the V equal to 100 cm cube row of table 2.1 as shown. Without delay, she pours 20 cm cube of cold water into the beaker. She stirs the water and measures the temperature of the mixture of hot and cold water. She repeats the procedure until she has added a total of 100 cm cube of cold water into the beaker. All the readings are shown in table 2.1. V is the total volume of the water in the beaker. Complete the column headings in table 2.1. Column headings means the title of the table. So this is a V, so you just copy it. This is 3 marks. The unit of V is cm cube and the unit of theta is degrees Celsius because they have given you the unit. So that's all. And C, plot a graph of temperature on the y-axis. So your y-axis must be theta slash the unit degrees Celsius. Right? So that is the temperature. Here we have the temperature. Yeah. And then on your x-axis, that is the volume of the water. So just put V cm cube. Now I'm using my ruler to draw. Okay, so I'm going to draw the x-axis first. This is my x-axis. Draw it first. Yeah, this is a line of the x-axis, a bit lower. So this is a line of x-axis, and this is my line of y-axis. Y-axis. Okay, so be careful. Okay, I draw my x and y-axis first before. Okay. Then here. Okay, I'm done with that. Okay, keep my ruler. This is my y-axis. Just make sure first. Y-axis is theta, x-axis is volume. Okay, I'm done. Now, you do not need to start the axis at the origin. Draw the best fit curve. It is not a straight line, right? So since I do not have to start from origin, I look at my x-axis first, volume. The smallest value is 100 and the largest value is 200. So I'm going to start with 100. Yeah, so here I'm going to start with 100. So this is 120, 140, 160, 180, and 200 is here. Easy. And on my y-axis, the smallest value is 49. The largest value is 87. 49 is the smallest value. Why not I just start with 40? And then 50, and then 60, and then 70, and then 80, and 90. And I'm done with the axis, labeling the axis. And now I am going to put in values, right? My points, I'm going to use blue. Now the first one, 100 cm cube, 87 degrees Celsius. 187, 89, 88, 87 is here. And then 120, 73. 120. Okay, let me look at the value here. 71, 72, 73 is here. Okay, be careful. Okay, this is my x. And then 140 is 65. 161, 2, 3, 4, and 5. This is 140. So it is here. 160, it is 59. So 59 is here. That's 160 right here. And then 180 is 54. 150. Okay, 54. 1, 2, 3, 4 is here. That's 180. So 180. Wow, 54 is right here. And then 200, the last one is 49. So 49 is this one. Wait, be careful. Okay, this is 200 right here. Yes, and I'm going to erase all these messy dot here. So I'm going to put here, erase, erase, and then erase this one right here, erase everything here. So, okay. Erase my vertical axis, but I'm going to redraw that, no choice. Okay, so I'm going to redraw that. Where's my black pen? And then luckily the ruler is in vertical direction, so I can draw it. So erase it. So, okay, this is my y-axis. And keep the ruler. Now I am going to draw this curve. I believe if you draw it on your paper, it will be even nicer. So this is a curve. This is a bit, okay, now let me redraw it because it is a bit out right here. Okay, here. I try my best. Okay, okay. Okay, this is a curve. So if you draw it on your piece of paper, it will be nicer, right? That's the answer. That's the graph. D, in the experiment, the student aims to investigate the effect on the temperature of the hot water as cold water is added. First part, Complete the sentence to explain why it is important to add the cold water without delay at each stage. The cold water is added so almost immediately. First thing is because the beaker is exposed to the surrounding air, and the heat would transfer outwards because the beaker is hotter, temperature is higher, so the heat would transfer outwards. So which causes the hot water to lose the heat, to lose the energy to the surrounding. When I added the cold water almost immediately, I just want to make sure that the heat lost by the hot water is mainly due to the cold water, and minimize the heat that lost to the surrounding. So I'm going to write that, minimize, okay? Without delay is to make sure heat, most heat, okay? Make sure heat lost by hot water is mainly gained by cold water, and to minimize heat loss to surroundings, because the surroundings temperatures are lower. Now, the second part, complete the sentence to explain the reason for stirring the water at each stage. You know, when you add the cold water at maybe one side of the beaker, so due to the temperature difference, the temperature of the whole hot water might not be the same. So the student has to stir the water before recording the temperature, is to ensure constant heat distribution, constant the heat distribution in, okay, water in beaker, of water in beaker. And okay, so that the temperature of water is constant throughout the whole water. That's it. Now, E suggests two ways to minimize the loss of thermal energy from the beaker during the experiment. Look at the beaker has no lid, so use lid. Use lid to cover the top of the beaker, to cover top of beaker. And then maybe you want to add the insulation layer, okay? Use insulation layer around the beaker, right? And F, name the apparatus that the student uses to measure the volume of the water. There's only one apparatus. Do you should remember? It is called measuring cylinder. That's the answer. Now, question number 3. A student investigates the reflection in a plane mirror. A ray trace sheet is shown in Fig 3.1. Draw a normal to line MR that passes through the center of MR. Wow, I need to use back the ruler. So the ruler, make sure, where is my MR? Okay, this is the MR. Hold on. Make sure that this ruler is horizontal right first. This is MR, and I have to draw normal that pass through the center of MR. So I'm definitely going to measure the center of MR. So let me see. Center of MR. I just roughly calculate from here. So if you print out the paper, you should know that from M to R, the distance is 10 cm. So you draw from M to the center 5 cm, from R to the center, this is 5 cm. But here I need to roughly draw it. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it is about 4.5. 1, 2, 3, 4, roughly about 4 point, okay, somewhere here. So just roughly draw normal. Okay. They didn't mention how long the normal should be, so I'm going to draw longer. So this is, I'm going to use a blue color to draw it so that you can see the difference. So I'm going to draw longer. Okay, from here and then longer a bit. Okay, longer a bit. And then place my ruler aside first. And then I have to label this as, label the point, label the normal NL. So this is L, this is N. And then label the point at which NL crosses MR, the letter B. So B is right here. Done. And then draw a line 10 cm from B at an angle of incident 40 degrees to the normal below MR and to the left of the normal. Label the end of this line as A. So to the left of the normal, it has to be 40 degrees from the normal. So normal is 90 degrees. 40 degrees from the normal, you take 90 minus 40, so you get 50. So use your protractor, you have to draw 50. Measure from normal is 40 degrees, yeah? Now draw a line and label about 10 cm. So you have to draw longer. So about 10 cm. So the end of the line is called A. Done. And this is 40 degrees. Now, done with that, the student places the reflecting face of the mirror vertically on the line MR. He places two pins, P1 and P2, on line AB. Mark the position of P1 and P2 with crosses X on line AB at a suitable distance apart for this type of ray trace experiment. Label position M1 and P1 and P2. Now, to make sure that the distance between the pin is being labeled as accurately as possible, due to the base of the pin, due to the thickness of the pin, the distance, okay, between P1 and P2 must be at least 5 cm. So you might want to label here, okay, P2, and then here maybe P1, as long as you make sure that P1 and P2 are far apart from each other, minimum 5 cm. It could be more than 5 cm. Right, that's all. See, the student views the image of pin P1 and P2 from the direction indicated by Fig. From the direction indicated by the eye in Fig 3.1, he places two pins, P3 and P4, so that pins P3 and P4 and the images of P2 and P1 all appear exactly one behind the other. The positions of P3 and P4 are shown on Fig 3.1. First part, draw a line through P3 and P4, continue until meets MR. Continue until it meets MR. Okay, P3, P4, make sure that I draw it. Okay, P3, continue until, okay, here, until it meets M. Okay. Okay, try my best. It seems like, okay, until it meets MR. Okay, but, okay. This is P3. This is P3 and P4. I think okay, I could not meet MR here, maybe because the normal that I drew wasn't exactly at the center. So if you draw on a piece of paper, this P3 and P4 would be able to meet at the center. So if you draw it correctly, right? So I'm roughly going to draw it out like this. So until it meets MR. Okay, so it has to meet at the center. So supposingly center is that. Right, okay, maybe because I measure the center of MR is very inaccurate. So that is why I would not be able to get the exact answer. So, but when you draw on the piece of paper, when you measure it 5 cm and point B is exactly at 5 cm from the two ends, you will be able to meet at the intersect of the normal. Now, the second part, measure the acute angle between this line and the horizontal line MR. An acute angle, this line and the horizontal line MR. And then you label this as alpha. This is actually called alpha. This angle is alpha. So I measure alpha, I got, actually the answer that I got was 45. Right, from the alpha, I got 45, or maybe you, okay, no choice, okay, or 49, never mind, I'll just put 49. Okay, alpha is 49 degrees. Okay, my alpha is 49 degrees. And D, the student turns the mirror through 180 degrees. He draws a new incident ray. I got 48 degrees actually. He draws a new incident ray at an angle of incident I equal to 50 degrees to the normal above MR and to the left of the normal, 50 degrees. Okay, so that means from normal 50 degrees, so I have to draw 40. So here, you don't have to draw it because the questions say that you need not have to draw it. So this is actually, okay, wait. Okay, let me draw it here. It's actually from here, but it is 40. Yeah, this is the one. And put this aside. To the left of the normal, he labels the end of this line is C. This line is not drawn. You may draw it. So I'm going to draw it. This is C. This is C. Done. And then he places two pins on the line CB and views the images of the two pins from near the top of right corner of the ray trace sheet. On Fig 3.1, draw a reflected ray 10 cm long from B and an angle of reflection beta equals to the angle of incident. Right, so from point B, angle of reflection beta, which is he places point, okay, on CB. He views the images. Right hand on Fig 3.1, draw a reflected ray 10 cm long from B with an angle of reflection beta equal to angle of incident. Label this line D. So you have to draw, okay, this is the angle of incident right here, and then angle of reflection must be the same. Okay, angle of incidence C is, wait, let me say. He places, angle of incident is 50 degrees. Here is 50 degrees. So you have to draw exactly the same 50 degrees on the right-hand side. Reflection what? So this one is 40. Okay, this is the one that you have to draw. So I'm going to draw it using blue color. So this is the one that you have to draw, and then you have to label it as, keep my ruler first. You have to label it as D. This is also 50 degrees. And now, suggest a relationship between alpha, okay, label the end of the line D. Suggest a relationship between alpha and beta. Justify your answer by reference to the result. So I would say that alpha equals beta. Why? Because alpha is equal to 49 degrees and beta is equal to 50 degrees. The difference between alpha and beta is 1 degrees, which is still within the limit of my experimental accuracy, because I think that 1 degree is quite small. So that is why I say that alpha could be approximately equal to beta. And state two techniques that you use in this type of experiment to obtain an accurate ray trace. So if you want to trace the ray, make sure that the pencil, okay, use sharp pencil to trace the ray, and make sure that, okay, sharp pins are used, or you could also say that, okay, the line that you draw must be as thin as possible, right? Sharp pins are used, or you say use small pins with the sharp end, right? That's all. Now, number 4, a student investigates the relationship between diameter and the resistance of wires. The following apparatus is available: wires with different diameters, instrument for measuring the diameter of a wire, meter ruler, ammeter, voltmeter, power supply. Other apparatus normally found in the school laboratory is also available. Plan an experiment to investigate how the diameter of a wire affects its resistance. Resistance R is given by the equation R is equal to V over I. Therefore, you cannot use ohm meter to measure the resistance of the wire, where V is the potential difference PD across the wire and I is the current in the wire. You do not need to write about the safety precaution. Okay, that's good. And in your plan, okay, I'm going to follow this step by step. Draw a circuit diagram to show the circuit that you use. I am definitely going to draw it here. So I'm going to draw it. First one, use the shape first to draw my power supply because power supply is given. So this is my power supply. And then after that, power supply is being connected to, I'm going to connect this power supply. Okay, I'm done. And I'm going to connect this power supply to a switch. Sorry. Okay. Okay, to a switch like this. And then I'm going to use a variable resistor as a safety precaution, but I'm not supposed to discuss about the safety precaution. And then after that, I am going to put my ammeter right here beside the power supply. And then, okay, after that, I am going to use, okay, this one. Do you know what is this? Because when this experiment is about wire, I need you to bear in mind, if this is about wire, you have to place the wire on top of a meter rule. Do you know why? Because wires are not 100% straight. Wire comes with kinks, we call it. Do you know what is kinks? Okay, wait, let me show you after I draw my wire here. So this is my wire. And then I keep my ruler first. So this is how our wire looks like. It is not 100% straight. So how are you going to maintain that the wire is always the same length all the time? So all you need to do is cut the wire and make sure that you tape the wire on the meter rule. You tape it, you fix the wire on the meter rule. So this is my wire. And then connect here, connect here, and then my voltmeter connect at the two ends here because I'm supposed to measure the potential difference across the wire to find its resistance. And okay, don't just stop right there because every diagram must be labeled. This is my power supply. Okay, this is a switch because I can use any apparatus that are available in the school laboratory. Remember, this is called variable resistor. These are called connecting LEDs. This is called my meter rule, and this is called resistance wire or just wire. And this is called voltmeter, and this is called ammeter. Ammeter must be connected in series with the power supply. If you want to play safe, easier for you, you just connect beside the positive or negative terminal of the power supply. Done with that. Now I'm done with my circuit diagram and I have to explain briefly how do I conduct the investigation. So I put this as methods. First, I say setup. Okay, before, setup apparatus as shown in the diagram because I drew. So I want the examiner to refer to my diagram. And I said that the diameter, because we are investigating, okay, the different types of diameter of the wire, is measured. Suggest an apparatus, because you're the planner, you have to suggest the apparatus that can be used to measure the diameter of the wire. It's measured by micrometer screw gauge. Done. And then length of wire is measured by meter ruler wire is cut to 100 cm and placed or tape on meter ruler. Done. And then fourth, power supply. Okay, because this is wire and we are using power supply, you need to understand power supply can measure from 0 volt to 12 volt. So I will have to explain that of 1 volt because this is wire. Wire is quite thin. So that is why power supply, I set it to 1 volt. Is switch on. Okay, and switch is closed. Readings on ammeter, which is I in ampere, and a voltmeter, V in volt, okay, are taken. Tell us, how do we calculate R? Resistance of wire can be calculated by R is equal to V over I. Done. And second, okay, and the last part for the method, always remember to write this. Repeat the experiment. Experiment is repeated with different, because we are investigating on different diameters that will affect the resistance of the wire. Different diameters of wires. We are done with the method. Now, move on. Step one, singular, yeah? One key variable to keep constant. So I call this as controlled variable. My controlled variable, I will put this as a length because length of the wire, right? I make sure it is 100 cm. Right? Or you can say the type of the wire. If you use constant wire, you make sure you stick to constant wire until the end of the experiment. Yeah, I'm going to write it one. And then next one, I have to draw a table. So how do I draw a table? My table would be, okay, table, just put here table. So my table would be maybe here diameter of wire because I use micrometer to measure. So the unit is mm. And then ammeter reading, which is I equal to ampere is the unit, voltmeter reading, which is V in volt, and the resistance in ohm calculation. So done with my table. Okay, just use a ruler, okay, to draw this. This is the table. And I'm done with that. Keep my ruler. And the last part here, okay, go up to the last part, explain how to use your result to reach a conclusion. We are investigating the diameter. So how to use the result, you have to read back. So this student is investigating the relationship between diameter and resistance. Could you see that I have values for diameter and I have values for resistance? So if you have values for both the physical quantities, conclusion, you can just put plot a graph of resistance against a resistance of wire. Okay, resistance of wire against diameter of wire to see the relationship. We are not supposed to give the result because we are just a planner. So if you want to plot a graph of diameter of the wire against the resistance of the wire, feel free to write that as well. So it doesn't matter which is on the y-axis, which is on the x-axis. Yeah, that's a wrap for May, June 2025, paper 61. So if you want more paper breakdowns, exam tips, hit that subscribe button and join our physics crew. See you in the next video. So remember, study smart, not just hard. Bye.